The idea of time and money go together in finance. The basic thought is that a dollar is worth more now than it will be at any time in the future. And there are a lot of reasons for that. The biggest one, of course, is inflation. Prices go up. And as pricing goes up, the earning power of an individual has to increase if they're going to be able to live at the same lifestyle. If not, then they're going to have to spend less money and have a reduced lifestyle. So the idea of inflation makes it harder for people to buy things, and it's necessary for businesses to be cognizant of the inflation that they're going to be facing in their marketing, in their operating expenses, in the salaries that they're going to have to pay. In all of their planning, a company is going to have to make sure that they are staying ahead of whatever the time value of money is. There are other things we might think about when we're considering the time value of money. We might think about opportunities for other investment projects. We might think about opportunities that would be of equal risk, and we want to make sure that we get the best return for it. Or we'd look at opportunities with the same amount of return and consider which one is the least uncertain, which one is the least risky. The timing that an investment takes to pay out is going to affect the price that you pay. For example, if somebody came to you and said, let me have $100 now, and I will give you back a certain amount of money in a year. You would want more if it was going to be happening in a year than you would if it was perhaps going to be happening tomorrow, right? If somebody comes to you and says, let me borrow $100 until tomorrow morning, if you trust that person, you could give them that money and you wouldn't worry too much about the time value of money. But if a year is going to pass, there were other things that $100 could have been doing for you. You could have put it into a 4% yielding account and at least gotten another $4 on your money. So how much would you pay if you required a 12% annual return if you were going to invest in something that would give you $100 in 1 year's time, or 3 years' time, or 10 years' time? Pause the video if you need to. Go back, look at the slides, look at the compounding, and think about what's going to happen for you to figure out that value. What you should have done was figured out the present value of $100 at some time in the future. Now, the only thing that's changing is the exponent. So we're looking at a 12% annual return. We're looking at a $100 future value. So we're going to divide $100 by 1 plus 12%. So it'd be divided by 1.12 raised to the first power or the third power or the 10th power. And the higher that exponent is, the smaller your present value would be. So this introduces a rule that you should understand about the time value of money, and that is the further in the future a cash flow is, the less it is worth. The standard illustration that we use to look at time value of money problems is a timeline, and this is not just a textbook thing. We use timelines in discussions around business propositions in offices all around the world. So I've been in many conversations where we're talking about perhaps a marketing proposal or perhaps an investment in a plant expansion, and somebody will put a timeline up on the board so that we can examine where the cash flows are happening, when are we paying money out, and when are we getting money back in. When we create a timeline for a TVM problem, we're going to start with 0 at the leftmost tick mark. So the first tick mark is always going to have a 0 because no time has passed. 0 periods have elapsed. And then we'll have a tick mark for each relevant period of time that passes. That might be months or quarters or years, depending on the conversation. The last tick mark is going to indicate the end of the last period being analyzed. So on that long timeline that's up at the top of the slide, we've got 10 periods that are being analyzed. There are actually 11 tick marks because the first one is time period 0. So the end of each tick mark is going to show the end of each period. Since we have 10 periods, we're going to have 0 point plus 10 more tick marks. Payments and compounding in financial contracts always happen at the end of a period. If a bank is promising quarterly interest, that interest will not be paid out until the end of the quarter. If we're talking about daily interest, it would be computed at the end of a day. When we're talking about business propositions, later on in the quarter we'll be talking about the value of a business project or the value of an investment in a business operation or the value of a marketing proposal. Then we might be able to look at something which is a little bit more flexible in terms of its timing. We might look at something which is going to last for 9.5 periods or something like that. But for the most part, we're going to be looking at compounding happening at the very end of each period. and that's how the math is going to function. Think back to that basic compounding example we talked about before. We had $100 that was invested at the beginning of the timeline, and we had $133 at the end of the timeline, $133.10. We had a 10% interest rate and 3 periods. So that timeline down in the lower left corner shows those appropriate tick marks. We have our 0 period with the $100 going out, and we have 3 periods later with $133.10 coming in. You can use that diagram to analyze the future value or the present value. And if you're going to make notes about it, I would encourage you to start making your notes the way that they are in the lower right corner, with PV and I and N and FV all clearly delineated. The reason that I want you to be clear in your notes for this is the way that we're going to be inputting things into the financial calculator. The better your habits are, the fewer mistakes and the less time it will take for you to work through these problems. If we're looking at a present value problem, our timeline might look like the one on the left. We've got a $100 outflow and then a little bit of math to figure out what's going to happen during those subsequent 3 periods. You can see the formula has the compounding and the result of 133.10, just like we came up with before. And the opposite is true. The timeline on the right shows the search for the present value based on a future value of 133.10 and a 10% interest rate in 3 periods. Take a look at the PV. In every case, I've listed the PV as a negative number, negative 100. This doesn't mean it has a negative value. Rather, it means that we've indicated that this is a cash outflow. Think about it this way. You have money going out of your checking account or out of your pocket and into an investment. When we're taking money out of our checking account and putting it into an investment, that's a cash outflow. When that investment matures and it pays us, in this case, $133.10, that's going to be a cash inflow. So we're going to indicate that with a positive number. The only reason we do this is because financial calculators require it to give you the correct answer. We call that the sign convention. The sign convention is that we will use a negative sign to indicate a cash outflow and a positive number to indicate a cash inflow. If we don't do this, our calculator won't understand what's a cash outflow and what's a cash inflow, and it will give you an error when you're trying to compute a positive, or rather a present value or a future value. When we're looking at TVM problems in the calculator, there's one more moving part that I need to introduce. So the idea of compounding or discounting for a single cash flow has those 4 that we've introduced before: the present value, the future value, the number of periods, and the rate of return per period. But for a TVM problem, we might have one more moving part that we need to keep track of, and that would be the intermediate payment. A payment which happens in between the beginning and end of each timeline. It's going to happen at each one of those tick marks that we've put on our timeline. For example, if you require a 12% annual return, how much would you pay for $100 to be delivered in 1 year? You'd pay $89.28. And the math is shown down below in the purple area. We have $100 divided by the rate of growth plus 1, so 1 plus 12% raised to the first power. We come up with that answer. How much would you pay for $100 to be delivered in 2 years? If you require a 12% annual return, you would pay $79.7194, almost $79.72. And how much would you pay for $100 to be delivered in 3 years if you needed a 12% annual return? If you do the math, you'd come up with $71.1780. But what if you had an opportunity to invest in something which was 3 cash flows in a row? You have 3 cash flows, each happening at the end of a year, and you require a 12% annual return. The amount that that's worth is the sum of those individual cash flows, each discounted separately. So we take the 89.2857, we take the 79.7194, we take the 71.1780, we add those up and we come up with $240.18. By adding together all the present values, you find the value of all of the cash flows in the stream. In the case of our magic machine, this would take a very, very large timeline. Each payment is going to have its own present value. By adding those present values up, we could find the total value of that stream of cash flows. But honestly, who wants to make 60 repetitive computations like that? We could set up an Excel spreadsheet to do it easily, but there is still an easier way, and that is that we can use our financial calculator. to do this. The financial calculator can compute the value of what's called an annuity using just those 5 inputs. When we're trying to understand an investment, we're going to make a timeline, and we need to remember that I and N are always going to be denominated in the same time increment. In other words, we would have monthly payments and a monthly rate, or we would have annual periods and an annual rate. What happens to the present value as time increases or as the number of periods increases? As N increases, the present value becomes smaller if we're discounting, or the future value would become larger if we were compounding. We're still going to have the sum of the present values be the value of a stream of cash flows. And if we're demanding, for instance, a 12% rate of return, the value of our magic machine would be the 100 divided by 1.01 plus the next fraction, 100 divided by 1.01 to the second, plus the next fraction, etc., all the way up to 60, giving us a grand total of 44.9550. But if we want to do that the easy way, if we want to use our calculator,